Okay, let's now start taking a look at how could we solve very simple equations that involve trig functions. So now instead of solving regular equations that just have x's and x squareds and so forth, let's take a look at how to solve equations that actually have trig functions in them. All right, so let's begin with some just ones to get us going. How about cosine of x equals a half? Now first of all, let's just think about what that means and then see how we'd go about solving it. If I take a look at the cosine function, I want to know what values of x make the cosine equal to a half. So this is 1. Here's a half. If I put that line there, the first thing you see is that there are a lot of places, right? There's a place over here, some x value that makes this equal to a half. Then there's a place here. There's also a place way over here, too. So the question is, how can I find all those solutions? Well, let's think about it. First of all, what you may want to think about is, well, what are those angles sort of roughly? Well, one's going to be sort of small, between 0 and pi over 2. So this is, in fact, a standard answer to a question, and the question is, what standard angle has cosine equal to 1/2? Well, if you think about it, it's 60 degrees, also known as pi over 3, and that's one of those standard ones that I hope that you may remember. So in fact, this answer right here, that must be at pi over 3. Pi over 3. Okay, so x could equal pi over 3. Okay, but now wait a second. How do I get this answer here? Well, that's something between 3 pi over 2 and 2 pi. And if you look at the sort of the symmetry of this picture, you can actually see what I'm doing here. What I'm actually doing here is the following. This is pi over 3 here. So from this big peak out to the one I want is pi over 3. That means from this big peak backwards out to here must be pi over 3 too. Because this thing has sort of perfect symmetry. You see how that length is the same as that length. So to find this point, what I should do is take 2 pi and subtract pi over 3. Let me show it to you in a different way. Maybe this way will make it a little bit easier to see. If we go back to the angles themselves, just the angle part, what I see is the following. One answer is 60 degrees, so that's pi over 3. But where else is the cosine going to be positive? Because I want the cosine to equal positive 1/2. All students take calculus. So over here is the other place where cosine is positive. So I have to have a reference angle of 60 degrees, or pi over 3. So I go down like this, and now this is a new angle. And how do I find that new angle? Well, look what I do. I take 2 pi and subtract the pi over 3. So it's exactly what I said here. Take 2 pi and subtract the pi over 3. That angle corresponds to this angle right here. So you can think of it this way if you want. All students take calculus. Here the cosine is positive, so I must be down here. It's 2 pi minus pi over 3. Or the other way is to look at this picture and see that in the graph. In any case, what I see is one answer is this, and the other answer is going to be 2 pi minus pi over 3. And what is that? Let's work that out. 2 pi minus pi over 3. I have to get a common denominator, so I'll multiply top and bottom here by 3. So I have 6 pi over 3 minus pi over 3. 6 pi minus pi is 5 pi over 3. So I see 5 pi over 3. So there's another answer, but in fact there are a lot more answers, because there's going to be an answer right here, for example. But notice that answer is the exact same sort of value as this if I just shifted it over 2 pi. See how I just take that curve right there and shift it over, I get right to here. And there'll be another answer way over here when this bends down, but that's the same thing as taking this answer and moving it over to here. So I'm allowed to now add any multiple of the period, and the period is 2 pi. So 2 pi n, I can add, and plus 2 pi n, where n is any number, 0, plus or minus 1, plus or minus 2, and so on. So in fact, there are infinitely many solutions, 2 sort of fundamental solutions, and then you can look at any sum, if you add on any multiple of 2 pi to these solutions, you'll get other solutions. You can see that graphically. So that's the way I can solve sort of a straightforward thing like this. Let's try one more just for practice. Let's take a look at sine of x equals minus square root of 2 divided by 2. Let's take a look at a picture first. Graph. And I want the sine of x to be negative square root of 2 over 2. So negative, that's down here somewhere. Pretty close to 1. So where is that going to happen? Well, you can see it again. It happens in a lot of places. It crosses it here, so at that x value right there. It also crosses here, so at that x value. So there are 2 x values right here. And let's see, over here there's 1, 2, and so forth. So how do I find this? Well, first I look at the sort of reference angle. I just look and ask, where does sine of x equal square root of 2 over 2? Well, that happens at 45 degrees, or pi over 4. But now I see the sign is negative, so which quadrant should I be in? Well, this actually tells me which quadrants I should be in. I should be in the pi to 3 pi over 2, that's the third quadrant, and 3 pi over 2 to 2 pi, that's the fourth quadrant. And so visually, the way you might want to think about this is as follows. If you think about sort of the angle itself, I'm going to want sort of an angle down here, and this reference angle to be 45 degrees, or pi over 4. And the same thing here, where this reference angle is pi over 4. So where are the angles themselves? Well, one angle looks like this, and the other angle goes way over to here. Well, how can I find those angles? Well, this angle, just look at this picture. This is going to be the straight angle, which is pi, plus pi over 4. So this is going to be pi plus pi over 4, which if you multiply top and bottom here by 4, you'll see 5 pi over 4. So that's this angle right here, 5 pi over 4. And how do I get that humongous angle? Well, one way of getting it is taking 2 pi and subtracting pi over 4, going once around and then removing that reference angle. So if I do that, so this angle here, that little angle that I just found, is this. That huge angle, how would I find that? Well, that huge angle would be just 2 pi minus pi over 4. Well, 2 pi is actually 8 pi over 4. So minus 1 would be 7 pi over 4. So that huge angle is actually 7 pi over 4. That's the second solution we found here. That must happen at 7 pi over 4. But of course, there are a lot of solutions, and those other solutions can be found now by just adding multiples of 2 pi, adding multiples of the period. So the answer would be x equals, well, 5 pi over 4 plus any multiple of 2 pi. And there's another solution, and a whole bunch of other families of solutions, 7 pi over 4 plus any multiple of 2 pi. So there's the answer, where again, I remind you, n can be anything of the form 0, plus or minus 1, plus or minus 2, and so on. So in fact, you can see when you're solving a trigonometric function, there appears to be always infinitely many solutions. And then in general, there may be a lot of solutions. And the first thing to do is to sort of find the basic solutions, sort of almost reference angle type things here, the core solutions, and then let's look at all the multiples that you can add to those that still make it a solution. Okay, up next we'll take a look at some slightly more exotic such equations and see if we can solve them using all the methods we talked about so far. Good luck.